let me move this out of the way here, otherwise it shows on the screen. Okay, so we are going to finish up the ellipses applications. So for the applications for the conics, that will be a calculator section, so you will be able to use your calculator here. You will be able to use your calculator on the test when we do the application section there. So we're going to start off with this first application problem, and I think we only have 2 to do. And this one is you have a whispering gallery, and that's what we talked about last time when you're in the Capitol downtown, and if you can be in that elliptical room and stand at one spot and whisper, and the person across the room can hear you, and they're standing on the focus points or the foci. That's what a whispering gallery is. So you have this hall, it's 100 feet in length, and it's a whispering gallery. The foci are located 25 feet from the center, and we want to figure out how high will the ceiling be at the center. All right, so I need to draw a picture. So I'm going to draw, this is the floor, all right, and then so this is going to be half of an ellipse, all right, because this is going to be half an ellipse, because if it were a full ellipse, you wouldn't have the floor, all right? The floor, if you want to think about the second half of the ellipse, it would be under the floor, but we're only going to draw half of the ellipse. All right, and I know the length of the entire thing is, of the entire floor is 100, right? Now, with these applications, you're going to have to designate a center. And the easiest thing to do is designate your center at the origin. All right, so I always put my center at 0, 0. So that means that I know if this whole thing is 100, what is the length of each half? 50, right? So if I had to put ordered pairs here, this would be 50, 0, and then this one would be negative 50, 0. Okay, and then the foci are located 25 feet from the center. So again, if we're here at 0, 0, and we're here at my center, and the foci are located 25 feet from that, I would have negative 25, 0, and also 25, 0. And then it's asking us, how high will the ceiling be at the center? So that is the distance here. Here's the center. I'm trying to figure that out from the center directly up. Now, we probably put on a little more information than we actually needed here, but I definitely wanted you to see how to put these ordered pairs on here, because sometimes it's really helpful if you can get them on. And then you can manipulate using some equations. Now, we have a couple of equations that go with our ellipse. So we have x minus h squared over a squared plus y minus k squared over b squared equals 1. Or it could have been reversed, where the a squared and the b squared could have been flipped. Depending on where it was longer. And then we also have c squared equals a squared minus b squared. So any of these are things that we might be using in the application problems, any of these equations. So we need to figure out what it's asking, what part it is, what parts I have, and go from there. So what do I know? Do I have any values?
A squared. A squared.
I have, well, yes, because what is A? A is 50. right? So what is a squared? 2,500. And what else did you say I had? C? Okay, C is what? 25. And C squared is what? 625. All right, so I've got A and A squared, C and C squared. And I also have H and K because I'm using 0, 0 here. And I need to figure out what it's asking me for. Is it asking me for an equation? Am I going to need to use one of the equations? Or is it just asking me for a part where I can use C squared equals A squared minus B squared? So what part is it asking me to find? It's asking me to find the height here, which would be B. So I can just use C squared equals A squared minus B squared, correct? So that would be C squared equals A squared minus B squared. And we said C squared was 625 equals 2,500 minus B squared. I'm going to go ahead and erase this because I don't need these. All right, so let's see, that would give me B squared equals 2,500 minus 625. So B squared is 1875. And then what would I have to do next? Square root. Yeah, and you can break it down. You can break it down into an exact radical if you would like, or you will be able to put this as a decimal. It doesn't matter. If you type into your calculator factor and parentheses 1875, let's see what this breaks down to first, and then we'll turn it into a decimal. Some people like to leave things exact. This will break it down to the prime factorization. Yeah, you use the letters at the bottom of your calculator to type in factor. What is it? 375 to the fourth? Oh, 3 times 5 to the fourth. I was thinking, that doesn't seem to be right. 3 times 5 to the fourth. All right, so what can I bring out? I can bring out 5 squared, which is 25, and radical 3. And that would be in feet. Or you can turn that into a decimal, which would be what? 43 point. Okay, so we'll say 43.3 feet. Either of those is acceptable, are acceptable. They both work. All right, questions so far? Anybody need another second? All right, let's look at the next example. So this next example, I think it has 2 questions that go with it. And we have a semi-elliptical arch bridge, and it's going to have a span of 120 feet. The maximum height of the arch is 25 feet. So before we look at the question, let's just draw what we have. Again, I always find it helpful to center at 0, 0. And it has a span of 120 feet. So that means if I had to put ordered pairs at the end, what would this be on the right side? 60, 0. And on the left side? Negative 60, 0. And it says the maximum height of the arch is 25. So that's here. This is 25. So if I had to put an ordered pair here, this would be 0, 25. Good. Ouch. Now, A asks us to find the height of the bridge at 30 feet from the center. All right, so let's see what that looks like, and then let's troubleshoot how we're going to set this up. So here's the center. I'm just going to go 30 feet from the right, okay, or to the right. So about halfway here and here. So this is 30 on the x, correct? We don't know what it is on the y, because that's a y value, right? So we need to find y. So is this something that can be solved using c squared equals a squared minus b squared? No, we actually have all of those parts. So I'm going to need to write the equation. So I'm going to start off, let's start off with the general equation first, without the 30 and the y in it. So with my center at 0, 0, I know that a is what value? 60. So a squared is 3,600. I know that b is what? 25, and b squared is 625. Since h and k are 0, that means I'm going to have x squared over 3,600, and that's under the x because that's the length on the x-axis, plus y squared over 625 equals 1. That's the equation for the whole ellipse. All right, are you guys with me so far? Okay, now I want to find this point that's on the ellipse when I know that the x-coordinate is 30 and I need to find the y-coordinate. So what do you think I'm going to do with those values? Plug in 30 for x and solve for y. Good. All right, and you're going to want to keep it exact until the very last calculation so that you get a good answer. So that means I have 30 squared, which is 900, over 3,600, plus y squared over 625 equals 1. 900 reduces down to what? 1/4, and I'm going to bring that over and subtract it. So I've got y squared over 625 equals 1 minus 1/4, which is how much? 3/4. How do you want to solve this? Let's cross multiply. So when you do 625 times 3, you get 1875, right? Equals 4y squared. Divide by 4. Let's go down here. So I have y squared equals 1875 over 4. I need to square root it. And again, we can leave it exact or we can do it as a decimal. And didn't we break that down? Did we break down 1875? 3 times 5, so 25 root 3. So we can make this exact. Sorry, let me draw that. So this would be 25 root 3 over 2. Or you could have turned it into a decimal, which would be 21.65, both of them being in feet, correct? Yes. All right, questions? Any questions? Okay, now we're going to be using the same picture, but now, excuse me, it's asking us to find the width of the bridge when it has a height of 15 feet. All right, so here, I'm going to erase this 30Y. I want to use the same picture. Fill that in. Okay, so now I'm finding it when we've got a height of 15 feet. So somewhere to the right, it's going to be 15 feet, correct? Also, somewhere to the left, it's going to be 15 feet. Correct?
No.
So this is our y coordinate. We are actually having to find what here? X. So that means here, this is some x value and 15. This is the opposite of that x value and 15. What we can do is find the width here, find this value, and then we can double it, and that'll give us the full width. Does that make sense? So we're going to find this part. We already have the equation. We have x squared over 3600 plus y squared over 625 equals 1. So now what we're going to do is we're going to plug in 15 for y, solve for x, but we have to double it because it's the width here and it's also here. All right, that x value is here and here. So we double it for the full. All right, so we plug in 15 for y and solve for x. So now I've got x squared over 3600 plus, and then 15 squared is 225 over 625 equals 1. You cannot square root both sides right now. You have to bring this over first. All right? Because of this variable here, that means that you would have to split this up into two perfect square binomials, which you wouldn't be able to do. So you have to isolate the x squared first. So you have to subtract. All right, so that's going to be x squared over 3600 equals, and someone do 1 minus 225 over 625.
16 over 25.
16 over 25. And then cross multiply. So you have x squared, 25x squared equals, what's 16 times 3600?
57,600.
What is it?
57,600.
57,600. And then divide by 25, so we get x squared is what? 2,304. Our next step is to do what? Square root.
48.
So you get x is 48. So what that means is this is 48 here, and this is 48 here, going on the left. All right, so if I wanted to find the total distance from positive 48 to negative 48, what would I do here? Multiply 48 by 2, and what do you get? 96. Does it make sense why we double it? I gotta find a space to write it. So 96 feet is our answer. All right, so with applications, you're either going to use the c squared equals a squared minus b squared, or you're going to put things into a general equation and then find either x or y. All right, so it's going to be one or the other for ellipses. Okay, questions before we jump to hyperbolas? How are we doing? Good? All right. All right, so we are moving to hyperbolas. And hyperbolas, it's going to be similar to your equation for ellipses. But the difference is you're going to have subtraction in there instead of addition. All right, and we have a couple of terms that we need to do as well. We have a center. All right, so let me go down here. You have a center, and then you have what's called branches. All right, so these branches of this first one, can you see it's branching left and right? Yeah. And this one is branching up and down. All right. The foci, or the focus points, are actually in what they look like sideways parabolas here. The foci are actually inside the parabolas, and then what connects the foci and the center is called the transverse axis. So it's kind of like your main axis or your major axis. It's which way these are branching. All right, and then your other axis is called your conjugate axis. All right, so do you see how when it branches up and down, your conjugate axis goes from here to here? All right, and that's vertex to vertex, vertex to vertex, and the center. All right, now it's going to be easy to tell which way the branches go, because if your x value is before subtraction, your branches are going to go left and right. So I'm going to line this up. So this is all with the right and left branches. So you have x minus h squared over a squared. A squared is always first, minus y minus k squared over b squared equals 1. When your branches go up and down, that means your y is first. And you have to be careful when y is first, because it's so easy to mess up the center because they're giving you k first instead of h first. So it's still y minus k squared, but over a squared, minus x minus h squared over b squared equals 1. A is always first, all right? It's not necessarily the biggest number here, it's just always first. Let me write that out on the side.
Is this a rule for hyperbolas?
Yes. So it's always before the subtraction. Not necessarily the bigger number. Okay, then of course we're still going to have the value to get that C, to get those focus points. So in this situation here, C squared equals A squared plus B squared. And that works for both of the equations, so I'm going to put it in the middle here. And I think it's easy to remember with the, between the ellipse and the hyperbola. The ellipse, the general equation has addition, and then when you go to find C squared, it's got subtraction. The hyperbola has subtraction in the main formula, and when you go to find C squared, it's got addition. So look for those little tricks to help you remember the parts to getting all these formulas down. Yeah, it is. It is. It exactly is. All right. Now, of course, you're going to have foci, and you also have asymptotes. This is actually, these are very easy to graph. Don't let the fact that I say it's got asymptotes, because you can see they're diagonal, You actually graph this without the asymptote equation. You just need to be able to use the parts to write what the equations are. So the more difficult part is writing all of the pieces. Graphing it is actually pretty easy. So first, once you find C, if your if your x values first, you're going to be tacking on the C to your x value, your x coordinate of the center, just like you did with the ellipses. So, foci here, well, let me write it in blue so it's color coordinated with the blue. Foci here, once you find C, you're going to do H plus or minus C, comma K. And to find the foci of the up-down hyperbola, when y is before the subtraction, you're going to have H and then K plus or minus C.
Are we going to have to be able to find the asymptotes? Like, are you going to ask us for those ones?
Yes, but there's a formula. All right, so you're going to have to remember the formula. So let's start here. And you're just going to have to write the equation. All right, you're not going to have to graph it with the equation. You graph it before the equation. These are really easy to graph. So your asymptote here is y minus k equals plus or minus b over a parentheses x minus h. And I'm going to show you how to remember it, all right? Or how, well, you have your own ways. This is how I remembered it. This one is y minus k equals plus or minus a over b parentheses x minus h. So the only thing that's different between the two of these is this one is b over a, this one is a over b. And this is just x minus h here, y minus k here from the center. Now, you know that when I was in school, I couldn't just straight memorize these. I had to come up with little things to help me remember which one was B over A and which one was A over B, because I could convince myself for both. Like, I could memorize it, but I had to have a saying, otherwise I couldn't remember. So the way I always remembered this one, I called X box. So I knew it was B over A, and this one I called YAB. It's silly, all right, and you don't need to use it. That's just the way I did it to help me to remember B over A as opposed to A over B. And once I knew YAB, I knew this one was the other one. So I don't know if that helps you or not. If it does, use it. If it doesn't, don't even think about it. Huh? Well, because it sounds like Xbox, but when I was in high school, we didn't have Xbox yet. So my brother was playing on the old school Nintendo, you know, with like the Nintendo NES. Yes, it's, I mean, we're talking old school. Yes, like Legend of Zelda, you know, like the first Legends of Zelda. We're talking old school. Anyways, so now you can think of it as Xbox because we've moved into, you know, better technology. But back then, it was just Xbox and YAB. Okay. Let's do some graphs. And like I said, these are actually pretty easy to graph. It's just getting all of the parts that gets a little tedious. Questions? Are you sure? Okay. All right. So here, we need to find the center, the foci, the vertices, and the asymptotes. And like I said, this is a lot easier to graph than it is to get all the parts down. So let's do the graphing. Let's start off with the center, just like we normally would. So here, what would my center be? negative 3, 1. And I'm next going to start off with a squared, and that's always my first value here. And do you see that it's not necessarily the biggest one?
Yes.
All right, so a squared here is 16, which means a is 4. And since x is before subtraction, that means my branches are going to be going what direction? Left and right. So what I'm going to do here is I'm going to go 4 to the right. I'm going to make a dot, and I'm going to go back to the center and go 4 to the left and make another dot. I'm not going to do anything else because I actually need to get my other points to make a box which will allow me to draw my asymptotes. So what I need from that is I need this value here, which is the b squared. So b squared is 25, which means b is 5. So from the center, I'm going to go up 5, and from the center, down 5. All right, are we all here? All right. So the next thing that we do is we use this to make a box. All right, so what you're going to do is you're going to go and connect all of the points you made with a box around the center. Do you see how that makes a box? So you start up here and you go out until you get to the blue point and then go down. Do you see how that box is?
Yeah.
All right.
Does that be dotting or something?
It could be solid, yes. It can be dotted or solid. I'm going to put it solid here just so you can see it, because I don't think the green shows up as well, dotted. All right, so there's my box, and this box is what's going to allow me to draw my asymptotes. I'm just going to connect through the center and the diagonals of the box. So between here and here, and again, these can be dotted or solid asymptotes. And then from here, I just take my blue points here, which were actually my vertices, and I just kind of sketch my right and left branches, kind of following along the asymptote line. So they're not difficult to graph. Again, the tedious thing is getting all of the foci and the asymptotes down. Anybody need another second? All right, so we already did the center, and we have the vertices down. So let's get those down. My vertices are 1, 1, and -7, 1. Check me on that. Yes. My asymptotes is going to be y minus k, so y minus 1 equals plus or minus. Now, x is first. Do I put b over a or a over b? B over a, x box. All right, so I'm going to put plus or minus 5 over 4, parentheses, and then x plus 3. All right, so this matches this inside here. This x plus 3 matches this inside, so make sure you're careful with that. There are no squares in here. All right, this is linear. Make sure your equation looks linear because the asymptotes are linear. And this is how you leave it. Don't distribute, you don't need to do anything else. Leave it. Hmm?
You don't need to add the one.
You can if you want. You can do whatever you want, but you can leave it like this. I personally would leave it. All right? And then the last thing we have to find is the foci. So we have to use our new c squared equals a squared plus b squared because we have to find this value c. So I know a squared is 16, b squared is 25. When I add those together, I get 41. And then I square root. C is a distance, so it's going to be the square root of positive 41. And then what do I tack that onto? Do I tack it onto h or k? H. So I'm going to say my foci are negative 3 plus or minus the square root of 41, comma 1.
Why is it plus or minus and it does have like c squared?
What? Hmm? Why is it plus or minus?
Versus when it says c squared.
Here? Because we have to have one going here and one over here. You're going to have a foci that's in the middle of this parabola somewhere and one that's over here. So if you do negative 3 plus radical 41, it's going to give you something this in here. And if you do minus radical 41, it's going to give you something in here. Did that answer your question? Okay. All right, what do I need to do on the next one to get it ready to graph? Divide by 36 to have it set equal to 1. So this would be, find a place for it, y plus 2 squared over 4 minus, whoops, x minus 4 squared over 9 equals 1. Now make sure you're careful with your center here because h is with x, k is with y. So make sure you're conscious about that because people will always flip those, all right? So your center here is 4, negative 2. Now here, y is before the subtraction, so my branches are going to go up and down. And I know a squared then is what? 4, because it's always first, so a is 2. And so from here, I've got to go up 2 and down 2 because that's under y. So up 2, down 2. So that means b squared must be 9, so b is 3. So from the center, I'm going to go right 3 and left 3 because that is under x. What do I do next? Make that box around the center, connecting those 4 dots that we just made. And what does the box help me do? Make the asymptotes. And again, you can make them dotted or solid. I just make mine solid here because it's easier, I think, for you guys to see. And then after I have that, I'm going to do my up branch and my down branch from the vertices. So not hard to graph, right? So the vertices we can just pull. Vertices we can just pull off of the graph. So 4, 0, and 4, -4. Asymptotes. So you have y plus 2 equals plus or minus, and what am I doing here? A over b, YAB, so 2 over 3, and then in parentheses, x minus 4. Again, make sure you check, because these are linear, you do not want to bring your squares into this. And the last thing I need to find is the foci. So I'm going to use c squared equals a squared plus b squared. So c squared equals a squared is 4, b squared is 9, so I get 13. C is the square root of 13, and where do I add this onto? The y. So we have 4 and then -2 plus or minus the square root of 13. No, I don't have you guys graph the foci. Okay, so now that we've practiced graphing, we're going to practice writing some equations. Are you guys ready? Anybody need another second? Good? All right. All right, so let's practice writing some equations now that we've seen the graphs. So I'm told I have a center at -2, 1. And again, these are not asking you to graph it. It's just asking you to find the equation. The coordinate planes are here just to help you if you need them. I have a focus point at -2, 6. And I have a vertex at -2, 4. So the way this is lining up, can you tell how my branches are going to go? Are they going to go left and right or up and down?
Up and down.
Up and down. So these are going to go up and down. So what does that mean? That means y has to be first. So right now I know I have y minus 1 squared over some number, and then minus x plus 2 squared over some number equals 1. All right, so I know a squared must be going under the y, and then b squared must be going under the x. Do I have either of those values? I have a squared. That's the distance. Now make sure you know that's the distance from the center to the vertex, and that's my dot in red here. All right, because remember the focus point is in the branch. It's inside that parabola. So what's this distance here? 3, so a must be 3. So a squared must be 9. So that's going to go under the y. Now, I don't have anything that tells me what b or b squared is, but I do have something that tells me what c is, which will allow me to find c squared. So what is C? 5. So C squared is 25. Now what can I do to find B squared? C squared equals A squared plus B squared. And again, we're just looking for B squared. So once we figure that out, we can just put it under there. So C squared is 25, A squared is 9. So what does B squared equal? 16? And that will go under there. All right, how are you guys doing? Okay, let's look at this next one here. I have 2 vertices that I'm given, so at -3, 9 and -3, -5. 1, 2, 3. One. Okay, so I have 2 vertices, and then I have the length of the conjugate axis is 8. Which one's the conjugate axis? Does that go in the direction of the branches or not branches? Not branches. Yes, kind of like attaching the co-vertices. Okay, so if I have the vertices and they're lining up like this, right now I know how are my branches going. They're going up and down again. So I know again y is first. Now, can I find the center from this? Yeah, I get where it is in the middle. Where is that going to be? -3, 2. Once I have that, I like to set it up. So I'm going to say y -2 squared over something minus x plus 3 squared over something equals 1. Well, I do have my distance from there to there, from the center to a vertex, is how much? 7. So I know A is 7, so A squared must be 49. All right, A squared is always before subtraction. And then I've got the conjugate axis is 8, which means it would go right and left how much? 4 each way. So it would go 1, 2, 3, 4 this way, 1, 2, 3, 4 this way. You don't have to do both of those. That just gives us the value of what letter? B. So B is 4, B squared is 16. And that's all it was asking us to find. All right, how are you guys doing? All right, now my question to you is, will you be able to complete the square for these? We're going to do 2 more problems. We're going to complete the square here for number 3 and graph this one. All right, because I want to complete the square here because it's got that negative attached to it. And then we're going to do one of the equations from number 4. And then when we get back on Monday, the last three equations will be our warm-up, all right? Okay, so we're going to graph this hyperbola, and then we need to find the center, the foci, the vertices, and the asymptotes. So I just want to help you guys complete the square here because you have that negative. So first things first, we're going to bring the 4 over and rearrange the terms. So I have x squared plus 8x minus 3y squared minus 6y equals negative 4. So this is going to be x squared plus 8x plus blank. I need to factor out a negative 3 from the y's. So that's going to be minus 3 times y squared plus 2y plus blank equals, I'm going to go underneath here, negative 4 plus a blank for the x's and a plus a blank for the y's. X is easy. Cut 8 in half, square it. That gives you what? 16. And we're going to cut 2 in half and square it. 1. But we're not putting 1 on the other side. We're putting negative 3. You have to do negative 3 times 1. So that'll give us x plus 4 squared minus 3, and then in parentheses, y plus 1 squared equals 9. All right, what do we do next to put it into standard form? Divide everything by 9. So I have x plus 4 squared over 9 minus y plus 1 squared over 3. So right now we know that its center is going to be where? Negative 4, negative 1. And since x is first, I know my branches are going to go which way?
Left and right.
Left and right. I know that a squared is 9, so a must be 3. So from the center, I'm going to go 3 right and 3 left. I know b squared is 3, so b must be square root of 3, which we know is between 1 and 2, right? Because the square root of 1 is 1. Square root of 4 is 2, so the square root of 3 must be between those. So just be between 1 and 2. It's kind of hard not to just, it's always going to look like the half mark for mine, but. All right, next up we're going to make the box. And again, I'm going to go solid. And that'll allow us to connect. And then we can draw our branches here, going right and left. We found the center. We can find the vertices easily. So -1, -1, -7, -1. Do we agree? Yes? Okay, so that's my vertices. Asymptotes. So you're going to have y plus 1 equals plus or minus. Now, was x first or was y first? B over a, x bar. So b is square root of 3 over a, 3, and then x plus 4. Again, always check to make sure that that is linear, that there's no squares in there. Last thing I need to find is my foci by doing c squared equals a squared plus b squared. So c squared is a squared was 9, b squared was 3. So c squared is 12, which means c is what? 2 root 3. And so where am I tacking that on? X or y? I'm tacking it onto x. So for the center, x was negative 4, so I'll have negative 4 plus or minus 2 radical 3, comma, negative 1. Whew. One more. Do you guys just want to do the first one there?
Yeah.
Anybody need another second? Are we good? Okay, so here we're given an equation and we want to write the general equation for it and then also write the asymptotes. Write an equation, yes. So this shouldn't be hard to write the equation, correct? So what parts do I need? Center. I need A. I need B. And I also need to know what I'm going to put in front of the subtraction. So is X going to be before subtraction or is Y going to be before subtraction? X. And we know X is before subtraction because the branches are left and right. Okay, so what's my center? 0, 0. And A is going to be 3. So A squared is 9. And that was that distance here. B is what? 4. So B squared is 16. So my equation would be x squared over 9 minus y squared over 16 equals 1. Easy, right? Now all we have to do is write the equation of the asymptotes. All right, so this will just be y, or y minus 0, which is still just y, equals plus or minus, am I doing b over a or a over b? B over a, x bar. So this is going to be 4 over 3 x. All right, so those last 3 problems, writing the equation, is going to be our warm-up for next time. But that gives you enough to do the hyperbola homework and then also finish those 3 ellipse application problems. All right? Any last questions? Do what? Oh. I did not do the foci here. My apologies. I did not do the foci. What do I need to find the foci? C squared equals a squared plus b squared. So c squared is 9 plus 16, which is 25. So C here is 5. And I'm going to put it onto X. So this would be 0 plus or minus 5, 0. Or you can write that as plus or minus 5, 0. Or you could even split it up into 5, 0, negative 5, 0. All right. That is it.